Hi guys, welcome to Learning Electronics Repair, and it's this thing on my bench again. So this is the Musicson P-802, 800 watts RMS per channel, 1600 watt in total power amplifier, okay? And the original fault on this is that we had some problem in the power supply board down here, some burnt out resistors, and we had short circuit transistors on one of the amplifier channels, in fact this one, okay? So in the first video of this, I actually diagnosed the problem, found the short circuit transistors. I didn't have them in stock, and I was discussing the fact I need to either replace all the transistors with another 10 which are matched to each other, okay, very similar gain, or find 2 replacement ones that will match to the other 8 existing ones. And I got some transistors, some replacements, but I then found that they were nowhere near a match for the existing ones. The gains were different. In fact, some of the existing ones didn't match the others either, 2 more, and I think they'd already been changed by somebody else. So it then got put on one side, waiting for some transistors. I eventually ended up with about 20 transistors, a mixture of the good ones from the amplifier, some new ones from 2 different sources, and I got 10 that pretty well matched each other. Not exactly, but the difference in gain was not very big for the transistors on each side of the amplifier. I think on one side, from the lowest to highest gain, the difference was 4, and the actual gain was something like 130, so let's say between like 126 and 130, that sort of thing, yeah. Very similar with the other side of the amplifier, so they pretty well matched. They were good enough. I put everything back together, put both amplifiers back in, and found the one I'd repaired still doesn't work. It was no longer blowing resistors up on the power board or anything like that. It just didn't give any audio on one channel. I then decided to figure out whether the reason I had no audio on one channel was something else in this chassis. So we have some input boards here and here. There's obviously the little power board in the back. There's some connectors. So we could have a problem with any of those, or with the wiring or switches. And to determine whether that was the fact or not, I decided to test both amplifiers on one side of the amplifier chassis individually. So the known good one in here was working. I put the bad one here, and I actually took a lot of cable ties off so I could extend the wires. One I actually made up an extension for, and got this into a situation where I could have it flat on the top of the amplifier like this. I can probe around and work on it. And I found basically that this amplifier module works in that position. This one doesn't work in that position. So the problem is definitely something on this amplifier board that stops this one from working. I then took the amplifier modules back off, had them side by side on the bench, and I took my multimeter and I just worked my way all through the circuitry in diode mode, looking for transistor junctions, diode. I did some tests in resistance range, looking for faulty resistors, power resistors and such like, and I couldn't see any difference really between the two amplifiers, at least not in the way of faulty components, yeah, on one of the boards. There was one difference to do with some components here which seemed to be possibly in different positions. We'll come back to that again shortly, but I decided at that point, because this was now a very long video, that I would get another piece of test equipment and again see if we can see a difference between these two amplifiers. And the piece of test equipment is called a curve tracer. What's called a Huntron tracker, which was a brand years ago. People generally call this a curve tracer. I've been asked to demonstrate the use of curve tracers on the channel, and I ordered one from AliExpress. And I said, let's wait till this arrives and then take another look at these, because this is a perfectly good example of where you would use this sort of tester. The good news is the tester arrived. The bad news is it's faulty. The good news again is they sent me another one, so it's not an issue as such, but it hasn't arrived yet. And the customer's asking me for this thing back. So I thought, okay, Let's have another look. I just wanted to double check that this really is not working, this channel. So I connected this one back up, and I noticed not only does it not work, but when this board is on here, the fan down here doesn't spin. The fan doesn't spin up either when this is attached. When this one is attached, the fan does spin up. It does so immediately when you first switch on. It doesn't seem to be temperature controlled, it just comes on. This channel is still working, but it sounded a little bit distorted. I didn't notice that previously. Okay. I then reconnected this one again to show you that the fan doesn't spin when this is on here. And I noticed that, in fact, I have a problem with this. So you see this resistor here? Can you see I'm moving it? And this one here, they just all loose at one end. So, although I tested all the components, I have at least 2 bad soldered joints here. And when I compared that with the working channel, this one is okay, but this one is also loose. And it's not as bad as those. It may be making a contact. This might be why this one is now somewhat distorted. So that's got us up to speed with these. What I'm going to do now is to take these PCBs off again, fix these bad soldered joints, have a look to see if I can see any more, because I haven't really examined the other side of these boards, and then try them again. The big problem with this is that you have these power transistors all bolted down and they're all soldered to these pins, and you can't get to the other side of the board easily to work on it. So what I've decided to do now is to actually take the PCBs off the heat sinks, and I will actually, when I come to test them, I'm going to test just the PCBs. So I'm not going to drive them at any amount of volume, just very quiet. I'll also get my thermal camera just to make sure nothing is overheated. I'm going to see if I can actually just run these boards with all the transistors mounted on them, but removed from the heat sinks, because I think otherwise it's going to be very difficult, especially if I have to keep probing around. Then I want to make sure what's on the other side or where the tracks go. Yeah. So let's dismantle them and let's have another look at these. Okay, so these are the boards. The one with the O on is okay, and the one with the X on is not okay. I've just spotted another problem while I was disassembling all the wires from this again, but this may just be because I'm repeatedly plugging and unplugging cables while I test these. And what I've noticed is that this connector here is loose. Yeah. Previously off camera I had the same problem with this one, and I resoldered this one. So it looks like these are just a bit fragile. Okay. These are the resistors I'm talking about, which seem to have a problem. So you can see that is completely loose. That is also completely loose, and they look rather burnt at that end as well, the PCB. This one is okay, but this one is also completely loose. But that one actually kind of like, as I pull it up, it's touching against something or pressing against something. This just seems to have gone. Okay. So I'm now going to unbolt all the transistors here and here. There's 4 bolts holding the PCB on, and then there's 3 transistors here also bolted to the heatsink. And then let's have a look at these PCBs. This is the one that was working. So these are the resistors we're looking at here and here. Okay. Let's see. So this one we can clearly see some damaged tracks there. The pad seems to have come loose, so I need to do a little bit of repair work on that one. And this one seems pretty much okay, and it feels pretty much okay. While we're here, let's look at the other heavy components. So it's mainly power resistors. Down here we will have the emitter resistors. These look okay, and to be quite honest, These feel okay. Yeah, they feel okay. So definitely this we need to fix, and we probably reinforce that as well at the same time. This is the connector which I soldered off camera, so it's down under there. I had to remove the transistors to do it, in actual fact, or at least that one. So that's okay. Let's look at the bad one. And we can see that this is broken. This is broken and looks like it's been possibly... Somebody tried to repair this before. Is that just a piece of the track? No, it's just a piece of the track. So those are both broken. The other ends, well, they don't look too bad and they don't feel loose. Yeah, that's this end here. That sort of feels okay. I can check the continuity there. Yeah, that's the other one. Okay. And then again with this one, all the emitter resistors feel okay. Yeah. Yeah, it feels okay. And this is loose on this one, okay? So that's down under there. I can probably just bend this up actually. Yeah, bend this out of the way a little bit. We can get to that. So let's solder that. Clearly broken connections. Okay, they soldered. They are soldered, but because I'm having to repeatedly insert this thing as I test it, I think I'll actually just run a wire from here to here and one from here to here as well. And they should be a little bit reinforced by that. I quite often do this using a leg of a resistor. If I leave them so long, I can still use the resistor. It's not like destructive to the component, but they're a good stiff bit of wire basically. Okay. See, still plenty on there. Now to fix this. Okay, let's clean all the old solder off. Okay, what do we have? Well, we need to clean it up a little bit. Let's see. So the tracks broke there. This is probably intact actually. You can just check this. Okay, so here it is okay. It is broken there. Okay, and obviously it goes to here. So I'm going to run our thing probably from here. We have a good connection around there, so I'm going to go from here across to here, and then from this one to this point. This then goes down over this way somewhere. Looks like it goes down, yeah, somewhere off down there. Goes quite a way actually. To there. Yeah, so stiff wire here, across here, bend it round, solder it to that. We can just check that on the other one, and we can see that it does in fact connect to here. Okay, here, here, and then off round to wherever it ran to there, I think, somewhere. Okay, so let's fix that. Once again, so these pads were connected together. I can always check on the other one. To there, to there, to there. Yeah, they do connect together. Yeah, okay. On the other side, well, that's bad on both of them. So this one, let's clean it up. Okay, from here, and this looks like a bit of a dry joint, so I'll resolder it to there. Goes there. Doesn't go to there, so it's broken. Goes there, and then from here goes to here, so it's broken there. Okay, let's fix it. Good. Good. Good, and then from here to here. Here, and that goes kind of around the corner there somewhere. Looks like it might go there. Let's have a look under this mess. Yeah, that just goes to here by the looks of it. Okay, and then this end, well, it looks okay, but I think I'll put a wire from there to there. Yeah, I mean, it looks okay. No, really, that is okay. This is solid, it's not loose or anything. And we clearly have a connection to there. What is that stuck in it? Oh, there's a thin bit of wire in here. No, it's a bristle off my brush. Bristles off the brush, that makes sense. Okay, not wire. So yeah, that's fine. My OCD tells me to solder it anyway. Yeah. Sometimes OCD is a good thing and sometimes it's a bad thing. Because there's the other side of the coin, knowing when to leave things alone, yeah. Okay, I trust it now. And then we have this one. So this one was okay, and it looks okay. That all looks fine. And on this one, we have the not okay. So let's fix this. Okay, so the pad's off. So again, wire. I'm now using a bit of old wire stripped off some LAN cable. I tend to use whatever's to hand, to be honest, guys. Okay, so we're going to solder from here. Let's loop around that. So this is the pin coming through the board. Let's just actually kind of like so we can wrap around it. This is why you need fingernails for this sort of work, guys. For those of you who don't like fingernails, we need them. I've never understood that aversion to fingernails, to be honest, but there you go. I know some of you guys do have it. Yeah, you've said about cutting fingernails. Okay, so that can wrap around there. It's not very tight, but I'm sure I can bend that over towards it. and then we can solder this back to here. Okay, let's make that a little bit tighter, maybe. Okay, then we'll just wrap it around the back of there. There we go. So solder it. I don't need to worry about this bare wire because there's quite a gap between the PCB and the heatsink because of the transistors which bolt back to the heatsink. So there's a lot of room here. There's no possibility of the board warping and this touching the heatsink. So I really don't have an issue with repairing it like this. If you guys have an issue, well, you know where to talk about it. Yeah, down there. Right. This one that's bending a little bit now. This is the pin that's coming through. Okay. Richie can bodge with the best of them sometimes, yeah. Dickie can bodge with the best, the Dickie job. Okay, so soldered. Or maybe I do a better quality of bodge. Yeah, I like to think so. Okay, so that's that problem solved. Just wants cleaning. In fact, this whole area wants cleaning. Okay, that's repaired. So this is the one that was the good one. Did seem to be distorting a bit on the sound. I'm pretty sure this is why. So you can see this is where the tracks come. We can just test this out. So from here, okay, we have a good connection to here, to here, okay, to here, yeah, to here. So that's all okay. And the other one, which was the one with no audio, from here, this doesn't connect to here, okay, it's just a scratch there. So from here to there, good, good, good. This one looks a bit dodgy. Let's have a look though. No, I think it's probably okay. Let's just get onto the actual pin. Let's have a bit of a look at that one. Maybe a bad joint, that actually. No, it's just the way the light's shining on that, but we can make sure we have a good connection. Yeah, we do. Okay, so that side's fine. Other side. Here to here. This is the broken trace. Goes to there, and then this effectively also goes to there. So we have a good connection, even if that trace, it's not actually broken, it's just kind of a bit loose, if you like. Okay. But it's bypassed, so it's not a problem. So that's okay as well. After getting this far with the repair, so you can see I've done that much of it, I made a video featuring this. So this is a curve tracer, and this is very good for comparing PCBs, especially if you have one good one and one bad one. And I demonstrated on this that there was a problem in these PCBs as an example, yeah. So this was the example I used. And let me show you what I found in case you didn't see that video, but I will link it to this one because this is a very useful bit of kit. So here's the curve tracer. We get quite a bit of glare on the screen, unfortunately. I connect the two ground leads, one to each amplifier, so ground on here, the other ground clip on here. So this is ground. It's marked ground on the amplifier, and that's all fact, okay. And now we can compare the two. And what I was doing in the other video was just looking around this part of the circuit board, because this is the front end where the audio comes in. So I put this into dual channel mode. I put a probe on each amplifier in the same position. So pin 1, pin 1. You can see that the trace is now the same on both. Yeah, I'll work my way through these. Pin 2, both looking the same. And all I'm really looking for is some difference, okay? Pin 3 the same. And when I got to pin 8, we see it's the same, a horizontal line. Pin 6. Similar but not the same, a bit different, okay? And pin 7, this is where we have the big difference. So look, on the bad amplifier, we effectively get a vertical line or close. That means it's near to a short. And on this one, we get a completely different. And the same applies on this other amp here, pin 7. Pin 7. So I can see between the two amplifiers, there's a major difference on that pin of the IC. The question is now, why? So what we'll do is look up the data sheet. Okay, and this is the chip. So it's TL071 low noise FET input operational amplifier. Okay, we can see they will handle up to plus or minus 20 volt supply. And here is the pin out. So pin 1 and pin 5 no connection. We have in inverted and non-inverted on 2 and 3, minus supply on 4, out on 6, positive supply on 7. And this is the pin where we see a big difference. We see some difference on 6 as well, but we see a big difference on 7. One is acting almost like a short, okay, on the faulty amplifier. The other one shows a curve. So let's have a look now to see what's connected to pin 7 and figure out, if we can, where the problem is. So this is our IC, and also here, both TL071. This is pin 7, which also connects to pin 7 here. Okay, and on the good one, measuring to ground, reads open. And the negative supply, which we know is on pin 4, which looks the same on both, reads 905 ohms. Okay, so 905 open. The bad one reads 124 compared to open. Yeah, 800, so closer to that 900 we were seeing on the other one. This is the big difference. Okay, so we need to figure out where these come from. There'll be somewhere on here something generating or supplying the 15 volts. Okay, I think it's generated on the amplifier board. I'm not 100% sure of that. I think it is. I've also noticed, by the way, there's a little clip on here before somebody says this is to do with bridge mode, and you only have it on one of the amplifiers. But just to prove the point, I've disconnected that, and we can still see on here 125, 800, open, 900. So that isn't related to it, but I'll take that off anyway, so they're both the same now. So the positive supply goes to here. Okay, so this power resistor, this is the positive supply to the op amps. Okay, and the negative supply comes from this one. So these are the plus and minus probably 15 on this end of the resistor. Okay, and we can see that on the other one, of course. Negative supply, positive supply. Okay, you can just about read the value on these resistors. So this says 2K7. I think you can just about see it there, guys. 2K7. Okay, the other one you really can't read. and the 2 on the other one you can't really read at all. Okay, but 2K7. Okay, so let's measure across the resistors. We know what they should be. So this one reads just settling down about 3K. There's probably a capacitor somewhere in the circuit. 2.9, 2.8. Okay. 284. That's pretty close to 2.7K. These are not very close tolerance resistors. This one, $2K8. This one, which is the good amplifier, in fact. That same thing with the capacitor, 2.76K, 2.65K. Okay, now these are the resistors where I had the broken track. So one end of the resistor is here and the other end of the resistor is there. That does look like a bad connection, but it tests okay. I can always put a bit more solder. We'll just look at the moment. The other one is here, so from there to there. And the same on the other amplifier. We just have to fix the one of them, okay. We can say something quite important here, I think, for the point of view of fault finding. Firstly, we can say that junction actually looks okay. That's soldered joint, yeah. Not dry joint. And secondly, whatever is causing the fault is on this end of the resistor. It's not something back through the resistor, because the 2.7K and we're reading 100 ohms. So the problem is on this end of, assumedly, the supply coming in through here through this resistor. Okay, the problem is on this end. Now, what do we have down here? Well, let's see if we can figure out where that supply actually goes. So from this end of this resistor, which is there, so it goes up to something here. This is a potentiometer. Okay. I think, does it connect to that? Actually, I'm not sure it does connect to that. There's something next to the potentiometer. Looks like a capacitor there. No, it's too far up. A wire link. So that, that wire link, that's the one that comes across to the chip, I think, pin 7. The chip is actually here. That is pin 7. Yeah, that's where the wire link goes. Okay, so it goes to the chip. It goes to here. This is somewhere a little bit in here. It's a little bit difficult to trace. Probably if I get a torch underneath, I'll see it a bit better. Okay. Goes somewhere into this, like the 3 transistors here and the diode. Okay. Let's check this on the diode, see if it's short. Okay. Because that would be fed through a resistor somewhere, you would think. 100 ohms seems sensible. Let's look at these 3 transistors, see if there are any shorts there. Another diode here. Let's check that one to see if there's a problem from there, the 100 ohms. If we don't see any problem around these transistors and the 2 diodes, let's take the chips off, eliminate them. If the problem is still there, then we need to trace it through a bit more. Okay, so diode mode. Zener. Should read about 0.7. If it's good. Reads very low. Certainly a lot lower than you would expect for a Zener. Let's look on the other one. Yeah. You see, so the short also shows across the Zener now. That'll be regulating voltage, so it could still be the chip, it could be the Zener. Could be something else powered off that rail as well as the chip. Let's see, so here's the other one. This is probably on the other rail, the negative rail. Hmm. 0.50. That was just on the threshold of the bleeper, this one. 0.56. Okay. That's also a bit suspicious. Yeah. So let's unsolder the Zeniths. I think probably I'll just lift one end. I might just take them out. See if we still see that low resistance. If we do still see, we'll unsolder the chips. If we do still see, we'll have a look around these transistors. Okay, we have a plan. Okay, I've just lifted one end of each diode. Let's have a look to see what they look like now. I'm still a bit suspicious of that thing. And this one looks bad to me. Okay, let's unsolder them. Okay, here they are. So BZX85C16, that'll be a 16 volt Zenith, 1 watt or more. We can get the data sheet. And another one, it's going to be the same, yeah. So this makes sense, plus and minus 16 volt Zeniths. This would be the plus and minus 15 volt rails for the op amps, which is what I expected. These are powered by those resistors with the bad soldered joints on. So what do they look like? Let's have a look first on the tester. 0.51. Well, one of them's faulty. One of them's duff. I'm not totally sure I trust the other one. I'm going to replace both of them, I think. So, yeah. Has that funny low resistance gone away now? On pin 7 of the op amps. So, to ground, pin 7. Yep, that's got it. No, it hasn't. Oh, it has 69k. There's a capacitor charging up somewhere. Okay, it's going high. I'm on the other one. I'll go to this one. They're both connected to the same supply rail. Okay, so that is on the bad one, and the low resistance is gone. So definitely problem with the Zeniths. Let's find a data sheet for these. BZX 85C16. Let's just try BZX85 because that's probably the whole series, different values. Okay. Yeah, BZX85 Zenith diodes, 1.3 watt Zenith. Okay, and then you see all the various markings. So C16, 16 volts, all between 15.3 and 17.1 because they're never exact. Okay. Yeah, unfortunately, I had a look around, but I don't see like a whole kit. I have 1 watt, but I already have the kit of 1 watt. I have some 2 watts, so I'm going to have to just order what I need, I think. In fact, if we're doing that, let's just look if we have the actual ones. Yeah, they're a bit more expensive, but we can say they are the correct ones, although they look a different colour to me. But no, look at the photos, some of that colour. Okay, so we just get the correct ones, yeah. At least we know that they will be right. Are the op amps any good? Are the transistors any good? I think we should have a quick look just to be sure. So what I'll do is, I'll tag a couple of 400 milliwatt 16 volt Zeniths on, just temporarily. So electrically these will be the same. Obviously I can't use these in the circuit. And look at the size of these resistors and the way this is set up. Obviously these are dissipating quite a bit of power. This is not really a particularly efficient way of getting the 15 volt rail. Okay, but if I tag these on, I can just test again with the curve tracer. We'll make a comparison around this part of the circuit as far as these transistors, and if it looks the same, then I think I will be happy to say that there's no other problems with this one. We can power it up and see how it runs once we get the correct Zeniths. Okay, so let's do this. If we still find some problems, we'll have to figure out what else it needs. Okay, so I've done that. We now have a couple of 400 milliwatts in. But as I say, I'm not going to power this up. I just want to make the two circuits electrically the same. Now let's try again with the curve tracer. You can obviously compare anywhere you want with this. It's just, I guess, what you feel like doing. Whether you want to probe on resistors or whatever, capacitors. Same, okay. Or if you just want to concentrate on the semiconductors, looks the same. Same. So I'm not learning particularly what all these patterns mean. I'm just looking for differences. At least one viewer said that if you use one of these for quite a while, it becomes kind of intuitive. You sort of know what to expect. And you can find effectively bad components just by familiarity with them, really. Okay, so this now has a circle type thing. And they're different. Okay, so we still have considerable difference between the two. Okay. Okay, so this one, same. Very similar. This is where the difference is still. So something on this rail is still different even after I've put those diodes in. We can look on the end of the Zenith. Actually, let's just go to here and on this one, the Zenith. That looks the same. Other end of the Zenith. Looks the same. Almost like a short actually. But one end of this will connect to ground, I would say, anyway. And that's the negative Zenith from what I can see. The positive one here reads the same at that end. This end, very different. Okay, so this one is showing what looks like a capacitor. This one isn't. Some sort of semiconductor junction because it's not a linear resistor basically. You know, it has a curve, a shape. Okay. And only something which is a semiconductor is going to give you this type of graph. How about these transistors? So we just go to the end of this one. That again looks very different. Okay. This one, different. So there's a lot of differences still around here. Right. I think we probably need to start removing stuff and then see if the differences are still there. Now we know these chips were powered via those Zeniths, and it's quite possible that something down here has had too much voltage, okay, and that would cause it to fail. So let's get the ICs off first and see if that tells us anything. The reason I'm going for the ICs first is because we know these have a maximum 20 volt rating, so that's probably the most likely thing to have been damaged. Okay, so we have the ones with the white marks off the bad one. I've taken the two off the good one, so both PCBs are the same again. The pads on here, some of them were actually not connected to anything. We saw that on the data sheet, and because the pads are not connected to anything and this PCB has been running hot for a very long time, a couple of those pads just came off, but they don't connect anywhere, so it really isn't an issue. Again, we can check with the data sheet to make sure, but I'm certain those are the ones which came off. Let's have a look now with the curve tracer. Do they look the same now? So we'll just go around the chip, or where the chip was, just see. Yes, those look the same, close enough now. Those also look the same. Yeah, very close. This one looks the same. This one looks the same. This one looks the same. This one definitely so. Okay, so we still have a problem with that. Is that this resistor? Yeah, it's this one. Other one also looks different. Okay, so we still have some obvious problem on here that they're not the same. We know it's not the chips because we removed the chip, so it ain't there. Let's see where this goes. So this is the other end of the resistor. Here. And that's the same. And this resistor from what I can see goes to here. And that's the same. So it's definitely something at this end. Okay. On both sides. Well, it's a matter then of figuring out where else this goes. Let's look at those potentiometers just to see if they are reading the same. So, one of them is here. Okay. That reads like a slope. They read the same. Middle pin reads the same. I think that's actually connected to this end. So it's not anything with the setting on the pot. Well, it's not that one. This one. Same. Same. They're all the same as each other. Okay. Where else does this go? Well, it actually goes. I've just had a look around here just to see where it's different, and this is the problem now. So you see this track here which is broken. This is one of those large resistors on the good amplifier. I repaired that track, but this one is obviously at some point broken. So we need to solder from here. I think it actually goes to here. Let's look on the other one. Yeah, it goes to there and then it goes along this way. I mean, this PCB is really old. That is also bad. I mean, I think we actually have a connection on that one. But I'm going to have to reinforce some more of these tracks. I mean, this is definitely not good. And this is the bad channel, if you like, okay? So more PCB repair. Okay, so I fixed that. This one is actually okay. This is where the pin of the Zener I tagged on is there. So I'll wait till I fit the proper Zener and then I'll fix this properly. But it's all right for now. So we have a connection there to here, okay, and we look at the other one here, okay, and then we have a connection now. This is where it was broken, so from here to here, okay, and then to there. So both of those and that one, okay, same on this one. So here, both of those and that one. So that is connected okay. So let's compare them now with the curve tracer and see if they both look the same though. Okay, so it's the same. It's the same. Here. Still different. That's where we have an open on that. There's no tractor there. Okay. The same. 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 So even having repaired that, I still have a difference. This one's looking like a capacitor basically. And this one has some sort of semiconductor device on it. So something that connects to here has got to be where the problem is. I'm going to have a look to see where this actually goes to. There's a component here. If I find the other end, that might give me some idea. It might go, well, we know it isn't on the potentiometers. It might go to where those transistors are. So let's have a quick look. So the transistors, one of them is here, and then two are there. Okay, so comparing the two, That's the same. This one, same. Close enough. Transistors, so one of them is here. Same. This looks like a short to ground, this one, yeah. That one. Same. This one. Same. Same. There, again, very different. So the next thing then I would say is to take this component out, this transistor, and let's see how it looks. Okay, here are the transistors. So both BC557, but they look different. I'd say one has been changed previously. Looking at both boards, all the other transistors are this colour, just this one. This one is off the bad channel. Put the white mark on it. Okay, we can test the transistors, I'm sure we will do. But let's see once more, do we still see a difference between our two PCBs? Because regardless if the transistor tests bad, we still don't know if there's any other issues. Okay, so here we go again. This is the best way to determine this. This is where the transistor was, where it read different. So let's have a look. That's like that. Still like that. So there's still something. And we're going to have to proceed until we figure out what is different, why this one sees some semiconductor junction, the other one doesn't see. I would say probably there's something open circuit on this one, which is why I see the capacitor there and not that. Okay. Well, it's obvious something's still different between these two. So the op amps are both removed. That transistor is removed. This is the pad which doesn't connect to anything, the same as that one. Somewhere out near, yeah, that one, that one. We can see this on the data sheet for the ICs. That's why the pads come off, by the way, because they're not attached to any tracks, and these are very old PCBs. As you can see, they're not stuck down very well. Actually, I still have those pads. I kept them on one side, but I'm not worried because it's no connection, okay? So with the curve tracer, we can see a definite difference. What do we see with the multimeter? So I've made a little mark where ground is on this now, which is actually here. That's that terminal we have on the other side, okay, the spade terminal. And, well, this end of this transistor is as good a place as any. So diode mode gives us 2.44 ohms, about 10k when it settles down. This one much higher, 800k. There are capacitors in the circuit, and sometimes this messes up with the readings, but we can see a difference there. What's it like on diode range on this one? Well, about the same in actual fact. Go back to ohms. That just reads open now. That one reads open now. I think this is capacitors charging, giving me some strange readings. Because the curve tracer is testing both positive and negative, let's just go the other way around with the positive to ground. Yeah, that gives a negative. That tells me full well there's a capacitor charge somewhere. And the same on this one. Okay. I think if we can just track out where that trace goes to. So we know this is the plus 15 volt supply. And then every component it goes to, let's have a look on the other side of that component with the curve tracer and see if we see any difference. The other possibility, I think, would be to order the Zener diodes and to power this up, okay? And then just check if this part of the circuit's working. We have audio in here, we know that. We have the first op amp, there's a second op amp, there's some transistors. We can test these transistors. We can test the op amps. I have TL071 anyway, but we can test them with the op amp tester. We can test the transistors, put them back in if they're good, otherwise easy enough to replace. So yeah, well, let me just even figure out exactly where this track actually feeds to. It may be going somewhere off on the board, somewhere different, and that's where there is a problem, why we see the difference on the curve tracer. Okay guys, so what I've done is I've taken a snapshot from my overhead camera, just put it into a drawing program. I have my pen tablet and I've drawn on it. So I've traced this through with the multimeter as well. What we have is, this is the positive 15 volt supply. So the resistor comes in from the high voltage positive 2K7 to here. And then to regulate that, the track runs along here. Down here, this is the Zener diode. The other end of the Zener diode goes to ground. Okay, and then we have a track that comes across here. This goes through a 4K7 resistor to something. I haven't bothered to trace what it goes through. And then it also goes through a wire link. So the orange ones are wire links. Okay, onto this track, which takes us to the transistor and pin 7 of the op amp, where we see the strange difference in the curve trace waveform. Okay, where else does it go? Well, it goes to this pin here. So this is just a 7-pin connector. There's nothing attached to this, and it also goes to an electrolytic capacitor here, the positive end. Okay, so what we can do now, we can compare here on this rail, positive end of the Zener, or just here somewhere. This is where we're seeing a difference. It'll be the same that we see here. Okay, we can have a look on the other end of this resistor to see if they both read the same from there. And the only thing left really after that is the capacitor. But this is a bit strange, because on the bad one I see a capacitor basically, and on the other one I don't, and the other one is supposedly the good one. Now it may look like there's a connection here, but there isn't. Okay, it's just a mark on the PCB. I've measured this out with the multimeter. There's not a connection there. That's just a bit of dirt or something. There's no connection. Okay, and this is the good PCB as well. The bad PCB, it's actually a little bit clearer that there's no connection there. This one is definitely clearer that there is not a connection. Okay, this is just hanging on. These are these little Zener diodes that I put on here. I do actually have a connection to the track, you can see it, but I really need to replace these with some proper ones up against the board. So we want to look at the curve tracer here, and then the other end of the resistor is actually there on both, and this is where the capacitor is here. Okay, this is the good one, supposedly. So we have something that switches on like a semiconductor in the negative, like a PNP transistor junction or something like that. Could be a diode, just depends on which way it's connected. And this one, we see just the capacitor. Okay, so we have that difference there. If we just go to the end of that 4K7 resistor, which I found, you can see there, which is here, and obviously we see the same waveform. Okay, same difference. And the other end of that resistor is here on this one, and it's here on this one. So that end of the resistor is the same. The only difference we see is on this end. The only thing I haven't really tested is capacitor, but I don't really see how the capacitor could be causing this, but we're going to desolder it anyway. So we see the capacitor here, here. Other end of the capacitor, I think maybe I'll go to ground or something. Let's have a look. Yeah, it goes to ground. Okay, so let's have a look by removing this capacitor. I honestly don't see how that could cause this. Having said that, I can't see anywhere else that this actually goes to. Yeah, that trace, I've figured out everything it connects to that I can see, and I've had a good look. Okay, off comes the capacitor. Let's try again. So this is the end of the capacitor. We still see that, okay? And this one is the same. Wow. Okay, I've learnt something there. Okay, so the capacitor was causing that. Let's just check those capacitors. And this is interesting, by the way, because with the multimeter, they look the same. So these things are 4.763 volt. Okay. So this one reads about 0.6. And the other one 2.85. So neither of them are particularly good. One is definitely much worse than the other one. I don't see much point in putting these on the SR meter because they're not low SR capacitors, but just out of interest, this is the one that reads the lowest capacitors. I'll just bend the leg. Okay, so bent leg, 0 the ESR meter. Okay, what do we have? Effectively open circuit. ESR above 100 ohms, and the other one the same. Okay, so I need to order the correct Zener diodes. I don't have them. Obviously, putting those substitutes in while fault finding was good, but I need to replace them. I'll just check while I'm placing that order to see if I have any of these are the right value. Otherwise, I'll just order some as well. Okay, and then we'll see this again. And I have another bit of new test equipment, which you will see before then, which I'm going to use when I power these up. Okay, so guys, marathon one got there in the end. That was interesting. Yeah, that was interesting. At least to me. I hope it was to you. Let me know down there. And I look forward to seeing you all soon again on Learn Electronics Repair. Ciao for now, guys.